So hello everyone, I Raghvendra Singh welcomes you all welcomes you all in this channel. So today we are going to discuss some concept of basic electrical engineering hearing, or we can also write in short BEEE. Okay, we are going to discuss some concept of it. So basically I think one video I have uploaded on electrical. So I'm just skipping one unit, although I will make video on that, but sometimes later I'm just directly in my module I'm doing directly third unit that is all about transformer. So it is all about transformer. हम ये सब जानते हैं कि ट्रांसफार्मर कहाँ यूज होता है, कैसे यूज होता है, क्यों यूज होता है. So we know basically we know some basic things about transformer, that why we use transformer. Simple answer is to control the power of electricity, like we step up, step down the voltage so that we can comfortably run our all appliances which we are using in our home. So the basic structure of transformer is something like this. Okay. Sorry, थोड़ा डायग्राम वैसा हो गया, but you may make it more accurately also. So these are some parts, like this is N, this is P, this is N, this is P. Oh sorry, this is NP, means power, this is NP, and this is NS. NP means primary, NS means secondary. This is NS, this is NS, and also here is NS. NS means number of turns of the coil. Okay, secondary, S means secondary, N means number of turns, and this is IS means current in secondary, and this will be IP, current in primary. Okay, so let's discuss some more concept here. This is volt, is AP, primary coil. This is primary coil, and soft iron will be soft iron, and this is what? This is secondary coil. Yes, secondary coil. Okay, and this is core one. So this was the basic structure of core one. So remember, always NS will be greater than NP. Okay, NS will be greater than NP. Just why? So that we can step up and step down the current. So basically I have discussed about structure. So working, so you all know that it works on mutual induction method. You all know that how mutual induction method works. So let's discuss some mathematical terms. So E is equal to minus d phi by dt. Okay, also you can write minus n d phi by dt. Okay, and EP is equal to minus np d phi by dt, d phi p, okay, primary, upon dt, and ES is equal to minus ns d phi s upon dt, d phi s upon dt. So suppose this is first one and this is second one. Yeah, so एक और चीज़ that phi means flux in first or flux in primary is equal to flux, doesn't matter. सिंपल जो बात है, जितना फ्लक्स यहाँ पे होगा उतना ही फ्लक्स यहाँ पे होगा, दैट्स वाई इट इज इक्वल टू दिस. सो आई कैन राइट हियर phi only. if we will do if we are doing that second equation is divided by first. Second equation is divided by first. Then EP upon ES, ES upon EP will be equal to ES. This minus will be cancelled. This d phi and d phi, this will be same. dt will cancel. So it will be simply ns upon np. Okay. So this is our condition. So need to remember it. Please remember this. Again, let me remember that it is number of coil in secondary, number of coil in primary. So yeah, one more thing, that we know that we use transformer to step up means this is primary and this is secondary. Step up means EP will be greater than ES and NP will be less than NS. Sorry, EP is less than ES and NP is also less than NS. Okay. And what condition about step down? You know, step down means high, high to low. So the same structure will be here, will be EP greater than ES and NP greater than NS. Okay. So now let's discuss one example on transformer. Because we have given transformer. So it is NP, it is NS, IP, IS. So some values are given, like NS is given 200 and NP is given 100, and it is primary coil. It is given 220 volt and 100 ampere, and we have to find ES and IS. So we know formula that ES upon EP is equal to IP upon IS. So it is IP in primary and it is, we have to find IS. So ES means ES upon EP. तुम दोनों वैल्यू में दी गई. So first of all we have to find ES. So ES upon EP is equal to NS upon NP. ये दोनों हमें दी गई हैं तो हम इसे ES निकाल सकते हैं. ES is equal to EP, this side EP is 220. So this is EP or EP is 220 into NS is 200 upon NP is, NP कहाँ है यार, NP is 100. So this to this cancel means ES is equal to 440 volt. ओके, सो ES हमेशा इससे ज़्यादा ही आता है EP से, बिकॉज सेकेंडरी में ज़्यादा कॉइल होंगी तो ज़्यादा तो आएगा ना. सो यहाँ पे अगर हम वैल्यू पुट करें, हमें निकालना क्या है, हमें यहाँ पे IS निकालना है, राइट. हमें IS निकालना, आई प्राइमरी हमें दिया है ये ES हमारे आ गया 440 अपॉन IS. IS is, we have to find IS. EP is 220 into IP is 10. So this to this will cancel, and now 220 upon 11, 220 upon 11. Okay, so it is 20 ampere equal to IP. Yeah, so simple that we know that अगर यहाँ पे कॉइल्स हैं तो यहाँ पे दुगनी कॉइल्स होती हैं, इस वजह से हमेशा दोगुना सब कुछ दोगुना आया है, लाइक IP भी दोगुना आया है और ES भी दोगुना आया है. ठीक है, सो नाउ लेट्स डिस्कस अबाउट ideal transformer, and practical transformer. Okay, ideal transformer, practical transformer. So okay, firstly let's draw the example of ideal transformer and practical transformer. Firstly, drive to structure of let me just solve it. Okay, so firstly EP, it is IP, it is IS, here will be NP, NS or ES. Okay, so yeah, first of all let's discuss the ideal transformer. बेसिकली आइडियल ट्रांसफार्मर कोई एग्जिस्ट नहीं करता है, फिर भी व्हाट इज आइडियल ट्रांसफार्मर. सो जितना हम इनपुट दे रहे हैं उतना ही आउटपुट आ रहा है, दैट इज़ कॉल्ड आइडियल ट्रांसफार्मर. ओके, हम जानते हैं कि पावर का फॉर्मूला होता है पावर इनपुट इज इक्वल टू AP into IP, right? And power output is equal to AS into IS, right? So basically आइडियल ट्रांसफार्मर क्या होता है, आइडियल ट्रांसफार्मर में क्या होगा कि ये 100% एफिशिएंट होगा, 100% एफिशिएंट विच इज ऑल्दो नॉट पॉसिबल. देयर विल बी no loss of energy. There will be no loss of energy. Means अगर कोई लॉस नहीं होगा एनर्जी, मीन्स पावर इनपुट will be equal to power output, right? पावर इनपुट विल बी इक्वल टू पावर आउटपुट. अगर कोई लॉस नहीं होगा तो मीन्स ईटा, विच इज कॉल्ड द एफिशिएंसी काइंड ऑफ एफिशिएंसी measure. Efficiency we do not write, this is symbol of efficiency, just see this. Output power upon input power output power upon input power into 100. Okay, so it is called the efficiency. So like output power is ep upon es, ep into ip upon input power, sorry, output power is es upon es upon is. Input power is ep into ip into 100. चूँकि it is ideal means input current is equal to output current, right? If it is ideal, then input current is equal to output current, means ip and is, this will be equal, means I can write here es, I can write here is, and this to this will cancel, and we will get eta is equal to 100%. This is the ideal transformer. Now till now ideal transformer does not exist. Okay, so now let's come on the practical transformer. So practical transformer, simply I can write also just which do not have 100% efficiency, which do not have 100% efficiency because energy loss is present in this transformer. So power input is always greater than power आउटपुट, बिकॉज हम जितनी पावर देते हैं उतनी पावर कभी हमें रिसीव नहीं होती. ओके, मीन्स ही इज ट्राइंग टू से दैट ई प्राइमरी इंटू आई प्राइमरी इज ऑलवेज ग्रेटर दैन ई सेकेंडरी इंटू आई सेकेंडरी. ओके, सो अगर प्रैक्टिकल ट्रांसफार्मर होते हैं मीन्स इट हैज़ अ loss of energy. So how many types of loss of energy, we will also see that. So now we will see energy losses in transformer. Now we will see energy losses in transformer. Okay, so total 4 types of energy. Sorry, camera was not able to focus. So total 4 types of energy losses in transformer. So first of all, let's draw the transformer. I'm just drawing roughly. And P, I, P, and S, I, S. So first problem is first type of energy losses is flux leakage. What is it? It is flux leakage. So like which type of flux leakage? Like here currents are passing from this, then it obviously some flux will be leaked, so it is called flux leakage. So for minimize what we can do is we use ferromagnetic means soft iron. पहले हम previously what we used to do is we use aluminium. Okay, so first loss was due to flux leakage, and second loss is loss due to resistance due to binding. Second loss is loss due to resistance, loss due to resistance, loss due to resistance, resistance, loss due to resistance due to binding, due to binding, due to binding. So also loss due to resistance, so loss due to resistance binding होना चाहिए. ओके, ड्यू टू बाइंडिंग, लॉस ड्यू टू रेजिस्टेंस भी होता है और लॉस ड्यू टू बाइंडिंग भी होता है. ओके, सो रेजिस्टेंस अगर हम जानते हैं, वी नो दिस वेरी प्रॉपरली दैट if the wire is very long, it means it has a high resistance. Okay, if high resistance means it will get heat. If any wire is applying very high resistance, means that that wire get very soon very heated. So we know heat formula is I square RT. Okay, and we know resistance is equal to rho L by A. To minimize it, we can increase area. अगर हम एरिया इंक्रीज करेंगे तो रेजिस्टेंस अपने आप कम हो जाएगा. गेटिंग माई पॉइंट. सो टू मिनिमाइज द रेजिस्टेंस, सो वी हैव टू डू, वी हैव टू इंक्रीज एरिया. मीन्स अगर ट्रांसफार्मर की एरिया यूज़ कर देंगे, और हाँ, और थिक वायर अगर हम तार को पतला कर देंगे तो ऑब्वियस सी बात है यार कि करंट स्मूथली फ्लो होगा और इट विल अप्लाई अ लेस रेजिस्टेंस. ओके, सो and this second loss is, sorry, third loss is hysteresis. I'm not sure with the spelling, please make sure it from your side. Hysteresis loss. So here is one diagram of hysteresis loss. It is just something like this. I'm not sure with the diagram. Okay, so like it is something like this. Sorry. This it is magnetization. Here is magnetization. Here is demagnetization. Here is demagnetization. Okay, yeah. So for this, but again for this for this loss, to minimize this hysteresis loss, we again use ferromagnetic iron. Okay, and now fourth is eddy current loss. Heat to decrease limited को. एडी करंट से भी काफ़ी सारा लॉस होता है. टू डिक्रीज इट we use limited core with insulating liquid. Okay, yeah, so that's all.